Let's take a look at a second combination circuit practice problem. Okay, so what we have here is we have a voltage, currents, and resistors for resistance for the loads and for the power source, and then we want to solve these. And so we're going to start by taking a look at Rule 1, which says look for items in series. Well, we do have, once again, items in series here and items in series here. So we can go ahead and start reducing this into this circuit. These two become this one, and those two become this one, okay? And without filling in any numbers, I can see that I can take a look at the circuit, and once I do Rule 1, no series. Rule 2, I see that these are in parallel, so I know that this circuit is going to reduce into this one, these parallels into this. So we just got to start moving this reduction along and getting the numbers, and then we work it back. So let's take a look at this first one. Series and in series. So these two are in series. This resistance was 330. This was 470. Okay. So I know that our total is equal to 330 plus 470. Okay. And so that is going to be 800 ohms. So I know that this one right here is 800 ohms, right? Okay. And then this one right here is going to be 560 and 220. So the R total there is going to be 560 ohms plus 220 ohms, which is going to be equal to 780 ohms. So this one is 780 ohms. Okay. So now as we work forward and we get into more complicated things, notice that these are almost the same. So you would think that any current that was generated here and then had to split, that it would be almost equal. Current goes through the path of least resistance. So this one right here is just going to have just a little bit more current flowing through here than this one is right here. We'll figure out how much exactly. Now then, these right here, these parallels get moved down to this one right here. Okay, so the issue here is that how do we get resistance of parallels? Well, it's 1 over R total is going to be 1 over 800 ohms plus 1 over 780 ohms. Okay, so we got my calculator here. I can go 1 divided by 780 plus 1 divided by 800 equals. And I got a very small number there, 002, but what I got to do is, because it's 1 over RT here, I need to flip my answer, and that's my 1 over X right here, and it gives me 394. I'll write it down here. 394.937 ohms. So that's my R total right here for this circuit. Okay. What else do I have? I see that I have 4 amps. They gave me the current here of 4 amps is what is being generated there. So I have the current and I have the resistance. So using my power wheel, my Ohm's law, I know that voltage equals current times resistance. So I can get voltage is going to be equal to 4 amps times 394.937 ohms. And if I take this right here and I times by 4, I get, and so my current times resistance gives me 1,579.75 volts. Okay. So that was current times resistance. So I can take that here, and it's 1,579.79 volts, and that just carries up because that is 1,579.75 volts, and we had my 4 amps here, and so we know I have 1,579.75 volts right there. Okay, so we're now going to start working backwards in our reduction. Okay, so as we work backwards, we take a look at this circuit and we ask, if it's series, then current stays the same. If it's parallel, then voltage stays the same. So as I back up here, what is going to stay the same? Well, this is a parallel, so what stays the same is the voltage. And so my voltage right here is 1,579.75 volts, and it's going to stay the same here, 1,579.75 volts. Okay, so my voltage stays the same. I can now solve this because I have voltage and resistance, and I know that I is equal to V over R. So for the first one right here, I'm going to have 1,000 579.75 over 800. And this one right here, I'm going to have 1,579.75 over 780. Here's ohms and ohms. So those are my two formulas right there. So let's see what this first one yields right here. 1,579.75 divided by 800 equals 1.975 amps. Okay, I got 1.975 amps coming here. And this other one right here, I got is this formula because this is a 780 ohms. 1,579.75 divided by 780 equals 2.025 amps. Okay, so there's my amperes there. So let's just think about this for a minute. So I've got some current coming out of here, and once it gets to this node, some of it goes left and some of it goes right here. Okay, so just under 2 amps goes this way, and just over 2 amps goes this way. And you can see that if you add these together, you're going to be pretty close to 4 amps. And sure enough, that is how many amps we were given right here. And so that is definitely looking right. And we said that current takes the path of least resistance. So here's 780 ohms is just slightly less than 800 ohms right here. And yeah, sure enough, just a little bit more went this way. All right. So when we move back up, we take a look. If it's series, current stays the same. Oh, it is series, so current is going to stay the same. So whatever current comes through this depiction here of the single resistor is really these two resistors. So this current is 2.02 amps. So I'm going 2.025 amps, 2.025 amps. Okay, and then this current right here. Here's 1.975. That must flow through both of these because they're in series. So I got 1.975 amps, 1.975 amps. Okay. Finally, I need my voltage. So for each case here, voltage is equal to current times resistance. V equals I times R. All right. So if I come to my first one right here, I'm going to have my voltage, which is going to be 1.975 times my current times my resistance. It is going to be 1.975 times 330 ohms. I get my voltage drop here, 651.75 volts. This one here is 1.975 times 470 equals, it looks like this one is 928.25 volts. Okay, I'm going to come over here now. This current in this path was 2.025. 2.025 times the first resistance, 560. I've got 1,134 volts. Okay, and then on this one here, I got 2.025 again. 2.025 times 220 ohms, 220 ohms, and I get 445.5 volts. Okay, so let's just check it again. My voltage, remember I can bring these up right here. I had 1575 volts. I had 4 amps. My total resistance right here was 394.937 ohms. Okay, that's what I had there. And so the voltage drop between the top and the bottom of these legs right here has to be 1579 volts. So let's just check it. So this first one here was 651, and this other one was 928. So if I go 651.75 plus 928.25, I get 1580 volts. So yeah, I'm pretty close to there. So these two, the combination of this added to this, the voltage drops, does give me 1580. And on this side over here, you can see that this one drops 1134 volts, and then this one drops 445.5. I get 1579.5 0.5. So if you add up these two voltages, they also equal the voltage drop. So my numbers look good when I check for the sum of the currents and when I check for the sum of the voltages. So there's practice problem number 2.